All right, let's dive in. This time, we're tackling something pretty mind-blowing. How intelligence emerges, not just in us, but maybe in artificial systems, too.
Yeah, really pushing the boundaries here.
Totally. And the excerpt you sent looks like it's from maybe a book or a paper.
Hmm.
It gets into some serious depths about self-organization, algorithmic growth, that kind of thing. So we're here to break it down, make it, digestible.
It's a wild ride for sure. What grabbed me right away is it challenges how we think about intelligence. Like, instead of a top-down design, what if it comes from the bottom up?
Yeah, that self-organization thing really jumped out. Like, how does order come from what seems like chaos,
Right.
The excerpt uses this skiing analogy. Like, you're finding the lowest point in a valley. You're not following a map. You're just reacting to the slope under your skis.
Yeah,
And somehow you end up at the bottom.
exactly. And that's the beauty of self-organization. Each little part, it acts on simple local rules, but together they create something way bigger. Like, think about a flock of birds.
Oh, yeah.
Each bird just reacts to its neighbors, but they form these crazy, complex, always changing patterns.
So how does this tie into, brains and AI? Because it's not like there's a tiny conductor in our heads directing every neuron.
Right. The idea is that even the brain, as crazy complex as it is, might develop through a similar process. Neurons connecting, interacting, strengthening, or weakening those connections based on experience. And over time, this self-organization, it leads to the intricate structure we call the brain.
No grand plan, just neurons responding to their little world, and boom, intelligence. That's wild.
It is a different way of thinking about it. The excerpt also mentions early cyberneticists, guys like Ashby, who dreamed of building artificial brains based on these principles. They saw self-organization as the key to replicating intelligence.
So they were onto this way back then. Guess the idea of an artificial brain has been around for a while.
Oh, yeah. But here's the thing. How we've traditionally approached AI, especially with those artificial neural networks or ANNs, it hasn't really focused on the self-organization as much.
Interesting. So how are traditional ANNs different? Like, what are they missing?
Well, with ANNs, we design the network structure first and then train it on tons of data. It's like building a car on an assembly line.
Okay.
Every part has its spot.
Got it.
But biological brains they're messier, they grow and adapt throughout life,
Yeah.
constantly making new connections, pruning old ones.
So you're saying that growing aspect is crucial, and that's where that algorithmic growth comes in.
Exactly. The excerpt argues that brains don't just learn, they develop. It's not just tweaking existing connections, it's about the network structure itself emerging through this algorithmic growth.
So it's less about programming a fixed structure and more about letting the network, build itself.
Yes. Imagine it like a chain reaction. Each step in the development triggers the next one, leading to a complex, intricate structure, like take lateral inhibition. During brain development, cells actually compete. Some win, become neurons. Others, they lose and fade away. It's like dominoes falling, each one affecting the next, creating a pattern.
Okay, I think I'm following. But wouldn't that make development kind of unpredictable? Like, how could you control the outcome?
That's the core question, and the excerpt really digs into it. It makes you wonder, when does development stop and function begin? Is it even possible to separate the two?
Yeah, good point. A car, you build it, then it functions. But biological systems, they kind of blur those lines.
Right. The excerpt even suggests aging itself might be a continuation of development. Genes, environment, constantly shaping the brain.
So we're never really done developing. Our brains are always changing. That's trippy.
It is. And think about the implications for AI. What if instead of engineering AI with fixed structures, we let them have this ongoing development, this algorithmic growth?
Now you're getting me thinking. Are we saying maybe our whole approach to AI is missing something? That we need systems that can grow and adapt more, like living things?
That's a big part of what this excerpt is poking at. It's making us think about intelligence in a new light, and whether we're aiming at the right target with our current AI approaches.
This is getting really interesting. There's this comparison in the excerpt that stuck with me. It talks about how an image recognition AI, even with more neurons than a fly's brain, it still can't match the fly's versatility in the real world. It's kind of humbling, right?
It is, and the excerpt argues that difference might be in something called embodiment.
Embodiment.
Yeah. A fly's brain isn't just processing info, it's controlling a body. interacting with its environment, making split-second decisions to survive. Its intelligence is tied to its physical existence.
So it's not just the number of neurons, it's how they're connected to the world.
That makes a lot of sense. Our AI systems are often disembodied, living in that digital space. Exactly. And that leads us to another big idea. Evolutionary programming. A fly's brain, any biological brain, it's the product of millions of years of evolution, shaped by natural selection, favoring those variations that led to successful behavior in the real world.
I see where you're going with this. You're saying our AI systems, even the super powerful ones, they haven't gone through that rigorous process of evolution. They're missing that real-world testing ground.
Precisely. And some researchers are trying to bridge that gap by actually evolving AI. They create virtual environments where, like, digital organisms controlled by evolving neural networks, they compete for resources and survival, like simulating natural selection to see what intelligence pops up.
Wait, so they're like running evolution in a computer. That's incredible. But even with that, are we still like skipping a step? It feels like we're designing the starting point, not letting the system truly develop from scratch.
You've hit a key point, and that's exactly where this excerpt takes us next. It challenges us to rethink what intelligence even is, and whether we're aiming for the right kind of AI with our current methods.
Man, I'm hooked. Can't wait to see where this goes next. Feels like we're just scratching the surface of something really deep here.
We are. And in the next part of our deep dive, we'll explore some even more radical ideas about how intelligence might emerge. Stay tuned.
Back again. Last time, we were talking about how a fly's brain seems to outperform even our most advanced AI when it comes to, navigating the real world. It's like we've got all this computing power, but are we missing something fundamental about how intelligence, how it really works?
And this excerpt really forces us to face that. It asks, do we even want AI to function exactly like a biological brain? Because, from an engineering perspective, a brain is kind of messy, kind of chaotic.
Right. It's like comparing, I don't know, a finely tuned race car to like a living, breathing organism.
Exactly. One's all sleek and efficient, the other's complex, always adapting. And for a long time, that was the dominant view in AI. The excerpt even quotes John McCarthy, one of the pioneers of the field. He said AI shouldn't be limited by the constraints of biology. He thought we could create human-level intelligence without mimicking all the messy details of the brain.
But isn't it interesting that some of the biggest breakthroughs in AI, like deep learning, they've come from letting go of that strict control? We're basically letting these networks learn on their own in a way that's more, I don't know, scruffy than traditional approaches.
That's a great point, and it speaks to the power of self-organization.
Yep.
By allowing for some randomness, some emergence, we've found these super powerful learning algorithms. It's like we're tapping into some force of nature we don't fully get yet.
So does that mean the traditional like engineered approach to AI, has it hit a wall? Do we need to embrace this biological messiness if we want to go further?
Yeah. The excerpt definitely makes a strong case for that. It talks about the work of Geoffrey Hinton, a giant in the world of neural networks. He's actually challenging some of the very methods he helped develop.
Whoa, that's pretty radical for someone who's like a pioneer in the field. What's Hinton proposing?
Well, he says we need to move beyond the flat, interconnected structures of traditional neural networks and create systems with more hierarchical organization, just like the human brain. He even suggests we might need to rethink backpropagation, a fundamental algorithm for training these networks, to find more brain-like learning mechanisms.
Okay, so instead of one big layer of interconnected neurons, we're talking about AI systems with multiple layers, different levels of abstraction, like the different regions of the brain. I'm trying to picture what that would even look like.
Think of it like building with Legos. Instead of just having a flat surface of bricks, you can create towers, bridges, all sorts of complex structures by stacking and connecting those bricks in different ways. Hinton believes that this hierarchical structure is essential for reaching a deeper level of intelligence.
That's a great analogy. So if we want AI to develop this kind of complex structure, how do we do it? Can we engineer it from the top down, or do we need to let it emerge through some kind of self-assembly process?
That's the million-dollar question, and it's something this excerpt really wrestles with. It suggests that self-assembly might be the key, but it also acknowledges the challenges, the potential risks of that kind of approach.
Yeah, I can imagine letting AI systems build themselves could lead to some pretty unexpected outcomes. How do we make sure they align with our values, that they don't, go rogue?
Those are huge questions, and they're at the heart of the whole debate about the future of AI. The excerpt doesn't offer easy answers, but it definitely pushes us to think really hard about what kind of intelligence we want to create and how we can guide its development responsibly.
It's like we're standing on the edge of this vast, uncharted territory. We've got this incredible power to create intelligent systems, but we're still figuring out how to wield that power wisely.
Exactly. And that's what makes this whole conversation so fascinating. It's not just about the technical nuts and bolts of AI. It's about our responsibility as creators and the ethical implications of what we're building.
This is deep stuff.
Yeah.
I'm starting to see why this excerpt really resonated with you. It's not just about AI. It's about understanding the nature of intelligence itself and our place in the grand scheme of things.
You're absolutely right. And that's what makes this deep dive so compelling. We're not just exploring the potential of AI. We're exploring what it means to be intelligent in the first place.
And there's still more to come. There's one last part of this excerpt we need to explore, and it might be the most mind-bending of all. Stick with us as we dive into the ultimate question: what is the true nature of intelligence? Okay, we're back for the final part of our deep dive, and things are about to get, well, pretty philosophical. We've talked about self-organization, algorithmic growth, even the idea that AI needs to be embodied to really get the world. But this last section, this last bit of the excerpt, it takes things even further. It makes us rethink what intelligence, what it even means.
Right. It's not just about, copying what humans do, which has always been the goal with AI. This excerpt asks, what if we're aiming at the wrong thing? What if intelligence isn't about replicating us, but about understanding the core principles behind it in any form?
So not just building machines that can beat us at chess or write poems, but cracking the code of intelligence itself. That's a pretty big goal, wouldn't you say?
It is. And the excerpt says we might find clues by looking at how intelligence, how it develops, how it unfolds. Think about a baby. They're not born with all the knowledge and skills of an adult, right? It takes years of learning, growing, adapting to their environment to reach their potential.
It's like the journey matters just as much as the destination. The process of development, how intelligence emerges, that might be the key to understanding what it is. But how does that apply to AI?
That's the question, isn't it? The excerpt suggests maybe instead of just force-feeding AI tons of data, we need systems that can learn and grow on their own, more like living things do.
So instead of teaching AI what to think, teach it how to learn.
Mm-hmm.
I like that. But wouldn't that be, incredibly hard, maybe impossible?
It would be a massive challenge for sure. But the excerpt points to some interesting possibilities. Remember that self-assembly idea we talked about?
Yeah.
Maybe by creating the right conditions, the right environment, we could let AI systems develop their own complex structures, their own ways of learning and understanding.
That's a radical thought, like planting a seed and letting it grow instead of trying to sculpt a statue. But wouldn't that mean giving up a lot of control? How could we be sure these self-assembled AI systems that they'd align with our values?
That's a crucial point. And to be honest, the excerpt doesn't give any easy answers. It recognizes that this path has a lot of uncertainty, potential risks, as well as rewards.
So it's not just a technical challenge, it's an ethical one too. We're not just talking about making machines smarter, we're talking about creating a new kind of intelligence.
Yeah.
One that might go beyond what we even understand. That's kind of exciting and scary all at the same time, isn't it?
It is. This excerpt really makes us face these big questions about the future of AI and what our part in it is. It's not just a tech discussion. It's like a philosophical journey into what it means to be intelligent and what kind of future we're trying to build.
Wow. This has been quite a ride. Started with self-organization and ended up thinking about the very essence of intelligence. It's like this excerpt opened up a whole universe of possibilities, but challenges too.
Definitely. And that's the power of a really good deep dive, I think. It's not just about learning new facts. It's about expanding your horizons, questioning what you thought you knew. It's about those aha moments that make you see the world differently.
Couldn't have said it better myself.
Yeah.
So on that note, I think it's time to wrap up this incredible exploration. But before we go, I want to thank you, our listeners, for joining us on this mind-bending adventure.
It's been fantastic delving into these ideas with you. And remember, the search for knowledge, it never really ends. Every question is a chance to dive deeper, discover new worlds of understanding.
So keep those questions coming, fellow deep divers. Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.
See